Alright, so here we go. For number 23, it says that we need to expand it. So how do you guys suppose that we would expand it? Just multiply, okay? This one's not going to, I mean, it is what it is. I guess there's no trick to this. So in multiplying, I got to go x squared times that. That's going to be 4x to the third. And then x times this, that's going to be minus 3x squared. Okay, so I just did that to both of those. Okay, now I need to do the next one right here. This times this is going to give me negative 12x squared, and then this times this is going to give me a positive 9x. Okay, now I'm going to do the 1 times both of them, so this will be a positive 4x, so positive 4x, and that's going to be a minus 3. Now, the reason why I do it this way is because then I just have to, I line up all the terms, and I just have to go 4x cubed, that's going to be a party, so that's 15x squared, that's going to be 13x minus 3. Bam. Okay, yeah. Yeah, just FOIL. This is just basically FOIL. Okay. Alright, domain. When it comes to domain, you need to remember a couple things. 0 underneath the denominator is bad, and then also you can't have a negative underneath the radical. So here we don't have any radicals, so I'm just looking at the denominator. So 3x squared minus 3, it can't equal 0. If it equals 0, then I have a problem. So I'm just going to solve for x. Add 3 to both sides. Divide by 3. Take the square root, so x is plus or minus 1. So that means that we have issues at positive and negative 1. If I was to draw this on the number line, you'd see this, negative 1 and positive 1. We'd have holes right here. Now x could be anything except those two values. Okay? So our answers have to be in interval notation, so that means that we need the brackets and the parentheses. So what's this number that's way down here? Infinity. Negative infinity. So that means from negative infinity to negative 1, and then we have to join it together, and so for this one you do have to put the union, okay? And then we have negative 1, positive 1, union, and then that's going to be positive 1 to that number that's way down here, which is positive infinity. So that's one, or that's what that would look like, okay? That's the answer. So here it says factor the following polynomial completely, okay? This one is a time taker upper, okay? There's no common factors, so we're going to have to do the P over Q. Luckily, there's no term in front here, so that means there's just going to be factors of 4. So, what are factors of 4? 2. More than that. So we've got 1, 2, and 4, right? Because 1 times 4 also gives us 4. Don't forget that this could be plus or minus, plus or minus, plus or minus. So before I start doing my synthetic division, I'm going to do a trick that I showed you earlier, where you could determine how many answers are going to be positive and how many answers are going to be negative. So here if I just look at how often it changes, so this is positive, so positive to negative is 1, 2, 3. So that means that there's going to be 3 positive. Okay, now if I was to evaluate this at a negative, this is going to stay positive. If I evaluate that as a negative, it's going to turn positive. If I evaluate that, it's going to stay negative. This one at a negative, that's going to turn negative, and then I have that. So there's only one switch there, okay? So 1 negative. So what type of number should we put in here? A positive number or a negative number? Yeah, it'd be better if we chose a positive number. So why don't we try what? 2. 2. Okay, so positive 2. So 1 gets a freebie. 2 times 1, that's going to be 2. That's 0. That's going to be 2. That's negative 1. That'll be negative 2. Oh, sorry. No, that is 0. Negative 1, and then that's going to give me negative 6. Now, who told me to put 2? What did I do?
2 times 0 is 0.
Oh, 0. That's 0. Good. Negative 3. There we go. That's better. 6. Thanks. I'll have to edit that on the tape. Okay. So that's going to be 2, and then good. Okay, now who told me to put 2? Good job. Okay. All right. So, anyways, this is what this means. This means that it says factor. So I don't need the solutions. Remember, this is a solution right here. So what is that as a factor?
X minus 2.
Good. X minus 2. Okay. And then here, this is my remainder. That's constant then x squared, and then x cubed. So that means that this is going to be x cubed, and then, well, we could say plus 0x, but I'll just write negative and say negative 3x, and then plus 2. Okay, can we use the quadratic formula for this part? No, so we have to do it again. We already know 2 works. What's another value that you guys would like?
1.
Negative 2? How about 1 work?
1 would work.
1 would work? Let's see if 1 would work. Okay, so I've got 1, negative 3, and 2. I did something wrong. What's wrong?
Placeholder.
Yeah, we got a placeholder, right?
Yes, we do.
Uh-oh. Okay, so we need to put a 0 placeholder before we put those other numbers because there's no x squared terms. So 0, negative 3, and 2. Alright, so 1 comes down. Let's see if I could do synthetic division correctly this time. So that's going to be 1. That's going to be 1. That's going to be 1. That's going to be negative 2. That's going to be negative 2. That gives me the 0. Good. Alright, so I still have this x minus 2. What is this as a factor rather than a solution? X, no, it's going to be the opposite, minus 1. Okay, and then here, this is going to be x squared plus x minus 2. Okay, now, can we factor this? Yeah, we can go even further. So I have x minus 2, x minus 1, and I'm going to quickly use the x. So factors of negative 2 that would give me 1 are x plus 2 and x minus 1. Okay, so we have 2 x minus 1s and then a negative, or x minus 2, and so bam. That's it factored completely. Okay, save your applause to the end, please. Okay, next. Solve the inequality. Now, obviously, this was a test because do you guys see an inequality?
Nope.
I don't. So, you guys want me to put an inequality? Or do you just want to solve it as a equation?
Just solve it.
Just solve it?
Yeah.
Okay, are there factors of 18 that would give me 3?
Nope. 6 and 3. 6 and 3.
6 and 3. So, using the x, and then negative 3. So that would be 6 and 3, negative, divided by your a term. So that means that the solutions are going to be opposite of this, so negative 3 and positive 6. Okay. So how would that change if this was an inequality? What would that mean? Right? We'd have to start looking at our parabola, because this is a happy face parabola, and seeing, is it shaded on the outside or is it shaded on the inside? Okay? So you'd have to pick a couple points. Here, I would look at it and say, okay, negative 3 is this point right here, and 6 would be right here. Is this a happy face or sad face parabola? Happy. So that means it's going to look something like this, okay? Right? So what I would do is I would just choose, like if it was this thing, choose 0, 0, 0. If you substitute 0 in here, is negative 18, is it less than or equal to 0?
Yeah.
Yeah.
So you should stop.
The reason why, well, it says solve the inequality, so I just been kind of going crazy with this one, okay? Because there is no interval notation when it's just 2 of these things, really, okay? Right here, it's saying that 0, 0 works, so that means the interval would be from negative 3 to positive 6, okay? If this had the inequality, but it didn't, so I'm just kind of making it up as I go. Okay, so negative 3 to 6, and they're both, since it has a line underneath it, that means it's a solid parabola, so it's going to be bracket, bracket. Okay? So I just put the inequality like that, and I'm showing you how to do that. Okay, 27. You guys remember the technique?
Yeah.
I1, negatives in the middle. Remember, this is I squared. This is I to the third. This is I to the fourth. And then it just keeps repeating. Okay, so I to the 5th, I to the 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, right? Any factor of 4 is going to be right here. So what I usually do is just say, okay, I know 32 is a factor of 4. 32 would be right here, so 33 would be one more. So then this has to be I. Okay? Here it says simplify and write your results in this form. So here this is 4 times 3. The square root of 4 is going to be 2, so I have 7 plus 2, and then since it's negative, the I is going to come out, and we have radical 3. Okay? Down here it says third degree polynomial, so that means it's going to have a highest degree of 3, and it gives me 2 zeros. Now, remember, if I had x plus 2 and x minus 1, we could come up with the solutions pretty fast by just taking the opposite, right? By saying, okay, that's going to be negative 2 and that's going to be positive 1. Now, could you work backwards? If I gave you the solutions, could you tell me what the factors were? You know what I mean? Yeah, and so that's what you're going to do here. It says one of the zeros is 4, so that factor would be x minus 4, right? And then it says one of the other factors, our solutions, I mean, is 2i, so that's going to be x minus 2i. And here's the thing we learned with complex numbers, is that if you ever have a complex solution, then its conjugate, which looks like this, x plus 2i, is also a solution. Okay? So if this was like a plus right here, then that means that this one would be minus. You would just have to fill in the blank there, whichever happens. So basically from this point, we just have to multiply. Now I know a shortcut whenever I'm multiplying two conjugates. Square the first, square the last, and then subtract them. Now I squared is negative, so 4 times negative 1 becomes a positive, and so this is going to be x squared plus 4, and then I multiply it times x minus 4. Now I'm just going to use FOIL. Okay, so that's x cubed plus 4x minus 4x squared minus 16. So cleaning it up, that would be the answer for 29. No waiting. It is what it is. Review the video. Okay, next one. Where am I? 30. Okay, so I have two functions, x squared, and then this other one, which is 3x minus 5. It says find the composition. That's what this means. Now, this isn't g times f. This is a composition, so you have to take the f function and evaluate it inside the g function. Okay? And b, what does that mean? I don't know what this means. Oh, a and b, sorry. I was like, what is the... Okay, so the g function, which is 3x minus 5, I'm going to substitute the f function inside of that. So it's going to be 3 times x squared minus 5. Okay, so that's 3x squared minus 5. All right, now, next one. F of g means that when I'm taking the g function and substituting it in. So instead of just x squared, I'm going 3x minus 5 squared. That means I got to multiply it like this, 3x minus 5. I'm thinking it's wanting us to do this. So that will be 9x squared, and then 25 plus 25. And then multiply those 15 times 2, which would be 30. So minus 30x. Okay? Now, if there was a number here, like a 2 or something, then that means that you would then, after you did this, you'd have to substitute in a 2 in place of the x. But this is as far as you need to go for these ones. Okay? Alright, last one we'll do on this video part is number 31. Okay, inverse. To find the inverse, that means just interchange x and y. Okay? Now, even though that sounds easy, for this one it's not going to be that easy. Another way of writing f of x is putting a y here. So I have 1 plus 3x divided by 5 minus 2x. So I'm going to interchange the x and the y. Everywhere I see a y, I'm going to put an x. And everywhere I see an x, I'm going to put a y. Now the tricky part about this one is that we have two y variables. Okay, we need to somehow make it a single y variable like this. So first what I would do is get it out of the denominator by multiplying both sides by 5 minus 2y. Okay, so let me try to clean this up. So if I distribute the x, that's going to be 5x minus 2xy equals, over on this side I just have 1 plus 3y. Okay? Now, since I need to get the the y by itself, I want to try to push all the y terms to one side and all the x or non-y terms to the other side. So I'm going to do 2 in 1 step here. I'm going to subtract the 1 and then add the 2x. So that's 5x minus 1 equals, I'm going to add the 2xy plus the 3y. Now, something that we've learned a while back is if I have two terms that have a common factor, I could factor out that and write it as a single y. Do you guys see that? Okay, now to get the y by itself, I divide both sides by 2x plus 3. And so I have 5x minus 1 divided by 2x plus 3 equals y. So that's the inverse. The only thing I'd change is just rewrite the y with f inverse of x.